is to calculate the slope from an equation. And in my opinion, this is the easiest way to determine the slope in most cases. If you take a look, this actually is part 3 if you want to add part 3 to your notes. Over here I have an equation what's called to be in slope-intercept form. So you have the equation already, and it should always be written as y equals, and the m, whatever number is in front of x, is where your slope will be located. So just like in the last video where we calculated the slope from 2 points and m stood for slope, m is going to stand for slope in slope-intercept form as well. Although when you see an equation, there's not going to be an m there. There's going to be a number in that spot. So m is kind of just a placeholder in my slope-intercept form right here. The plus b is the y-intercept. We'll talk about that more at a later date. So if I'm looking at these 4 examples along here and I want to find out what the slope of this line is, all I have to do is look at what number is in front of the x value. So right here I see the number in front of x is a 3, so the slope is 3. And I'm done with that. The next example, I see that the number in front of x is a -2. And there's the slope for that line. When I look at the third example, I see that there is no x. And there's no x because it got multiplied by 0. So no x, 0x, 0 times anything makes it disappear, makes it be there's no value. So in this case, the slope is 0. And if you remember from our video in part 1 of calculating slope, an equation that has a slope of 0 must be a horizontal line. There's no way it can't be. Now this equation over here, many people would be tempted to say that the slope is 2 because they look at the number in front of x, they see it's a 2, and they're done. The only problem with that, though, is that this equation in the orange does not have, it's not in the form y equals. Y is not alone. So my job is to manipulate these variables and numbers so that y is on one side of the equation all by itself. Now, in my opinion, it's an easier fix if I were to take this y value and move it to the right-hand side. The reason I want to move that is going to be one fewer step than normal. This, actually not fewer steps, just a little bit easier steps. Because this y has a minus sign in front of it, I would add it to both sides. What that does is it's going to move the y to one side of the equation by itself, so it's no longer with the x. And not only does it do that, but it makes the y a positive value. Because if you look at the original formula way over here, and I don't know how to turn my mouse into a pointer, but way back at the beginning of the notes, if you look, the original formula, y is by itself and it's positive. And that's how you need it to be before you can determine any slope. Now in my equation, the orange equation, y is not by itself yet. Y has this plus 3 over here. So I need to subtract 3 so that I can have y all alone. And if I do that on the left, I can't really subtract 3 from a 2x because they're not like terms. They don't both have an x attached to them. Miss Wagner might have said they don't have the same last name. So instead all I would do is write it as y equals 2x minus 3. Now when I look at the number in front of x, I see that it's 2. So this line has a slope of 2. You might be wondering, well, yeah, I have a slope, positive slopes in here. I have equations that have negative slopes. I have equations that have a slope of 0. What about slopes equations for horizontal, I'm sorry, not horizontal lines, but vertical lines? Let me change my color here. Vertical lines. Because their slopes are undefined, they have their own little form all by themselves, and they would be the form x equals some number. So it could be x equals 12. It could be x equals 3. It could be x equals 7. But anytime you're asked to graph a line on a coordinate plane and all you have is the letter x, you can be guaranteed that that's going to create a vertical line. And we'll talk more about graphing those kinds of lines in a later video.